Buckle up, everyone, because today we're diving into something truly mind-bending: the multiverse. Imagine our universe as just one tiny island in a vast cosmic ocean of universes.
That's right. And, it might sound like science fiction, but this idea of a multiverse, it's something physicists are seriously considering.
Really?
Yeah, it might actually hold the key to some of the biggest mysteries in our universe.
Hmm.
We're going to be talking about some pretty complex physics using excerpts from a paper
Okay.
called Evidence for the Multiverse in the Standard Model and Beyond. And what's really intriguing about this paper is that it suggests our very existence, like down to the stability of atoms, might hinge on the existence of a multiverse.
Okay, now you've got my attention.
Yeah. So the paper dives into this concept of naturalness,
Okay.
which basically explores how sensitive the universe's properties are to its fundamental constants.
So things like the speed of light or the strength of gravity.
Exactly. Those are constants.
Got it.
And if those constants were tweaked even slightly, the universe as we know it would be completely different.
So does that mean if these constants were even just a little bit different, we wouldn't even be here?
Precisely.
Yeah.
And this is where things get interesting, because some of these constants seem incredibly fine-tuned, almost as if they were carefully calibrated for a universe that could support life.
So it sounds kind of like the universe we live in. It's almost too perfect to be random.
Right. It's a concept that's often called the fine-tuning problem.
Okay, I'm starting to see where this is going.
Yeah.
So is this fine-tuning like one of the reasons why some physicists think there might be a multiverse?
Yeah. It's a major piece of the puzzle.
Huh.
For example, let's take the cosmological constant,
Okay.
which represents the energy density of empty space. And it's basically what drives the accelerating expansion of the universe.
So what we call dark energy?
Exactly. The problem is the observed value of the cosmological constant is way smaller than what our current theories predict.
Huh. That sounds like a pretty big problem. How do they explain that?
Well, one way to explain it is to consider the possibility of a multiverse. Imagine, like, countless universes exist, each with its own unique cosmological constant. In most universes, this constant would be too high, and that would lead to rapid expansion, preventing the formation of stars and galaxies.
Okay.
But in a tiny fraction of universes, the constant might be just right, allowing for, structures like ours to emerge.
So we just happen to be in one of the lucky ones. Almost like winning the cosmic lottery or something.
That's a good analogy. But the paper takes this a step further and proposes this fascinating idea
Oh,
of a probability force at play.
probability force. What's that?
It suggests that certain values for these constants might be inherently more likely than others.
Wait, so you're saying there's like a force that nudges universes towards specific values? That's wild. It sounds like there's like a guiding hand shaping reality.
Yeah, it's a mind-bending concept, but it could potentially explain why we find ourselves in a universe that seems so perfectly fine-tuned for life. Almost like there's an underlying principle favoring universes where observers like us can exist.
Wow, I'm really starting to wrap my head around this. So we've got this unnaturalness with the cosmological constant.
Right.
And the multiverse could be the answer. But this paper dives even deeper, right? It also talks about this fine-tuning in nuclear physics.
Yes, and here's where we see this idea of observer selection play out on like an even more fundamental level. You see, the very existence of stable atoms, the building blocks of everything around us, depends on this remarkably delicate balance in the masses of subatomic particles.
Okay, so we're talking protons, neutrons, electrons, the stuff that makes up you and me.
Exactly. And the paper highlights how if the masses of these particles were even slightly different atoms as we know them wouldn't exist, the paper actually uses a visual representation, a diagram they call the observer region.
Observer region.
Yeah. To illustrate this point, think of it like a map of all possible universes, each point representing a different set of values for the fundamental constants.
Gotcha. So this observer region is basically that tiny sliver of possibilities where a universe like ours could even exist.
Precisely. It shows how incredibly narrow the window is for a universe to have stable atoms, stars, and ultimately life as we know it. For instance, the neutron is just slightly heavier than the proton. This tiny difference allows for neutrons to decay under certain conditions, a process that's crucial for powering stars.
And if that mass difference was off?
Even a tiny change, like a fraction of a percent, would mean no stable hydrogen, no stars, and a vastly different universe.
Wow. It really makes you think about how interconnected everything in the universe is. So are we really just incredibly lucky to be in the sweet spot of the observer region? Or is there something more to it, like this whole multiverse idea suggests?
That is the question that physicists are grappling with, and the multiverse offers a compelling explanation. If countless universes exist with different sets of constants, then it's not so surprising that we find ourselves in one that allows for observers like us.
Yeah, I guess that makes sense. It's kind of like if you're searching for a specific grain of sand on a beach. If
Yeah.
you only have one beach to search, the odds are astronomically against you. But if there are countless beaches, each with trillions of grains of sand, then finding that specific grain becomes much more likely.
That's a great way to put it.
So the more universes there are, the higher the chances of one having the right conditions for us to be here. But the paper also mentions a third area where this fine-tuning and this multiverse idea comes into play, right? Something about the Higgs boson.
You're right. That's where we'll pick things up next. The Higgs boson, the particle responsible for giving other particles mass, might be another clue pointing towards a multiverse.
That's a great cliffhanger. Can't wait to dive into that in part 2. This whole concept of the multiverse, it's truly mind-boggling. But this paper, it makes such a compelling case. The idea that our universe is just one of many and that our very existence might depend on this vast cosmic landscape, it's both humbling and awe-inspiring.
It certainly challenges our perspective on our place in the cosmos and opens up a realm of possibilities beyond anything we could have imagined.
All right, so last we left off, we were about to get into the Higgs boson and its possible connection to the multiverse.
Yeah.
So remind me again why this particle is so important.
The Higgs boson, it's crucial because it gives other particles their mass. Without it, the universe would be a very different place.
Yeah.
No atoms, no stars, no planets, and certainly no us.
Right. But you mentioned there are some mysteries surrounding the Higgs boson, right? Something about its mass not quite adding up.
Yeah, that's the so-called little hierarchy problem.
Okay.
The Higgs mass, as measured by experiments at the Large Hadron Collider, seems surprisingly low compared to what our theoretical models predict.
So another case of unnaturalness, like we talked about with the cosmological constant and nuclear physics. Could this be another clue pointing towards a multiverse?
Absolutely. The multiverse could explain this apparent discrepancy. Imagine a scenario where there are countless universes, each with a different Higgs mass. In most universes, the Higgs mass might be extremely high, leading to conditions incompatible with the formation of, complex structures. But in a few universes like ours, the Higgs mass might be just right, allowing for the emergence of stars, galaxies, and ultimately life.
So we just happen to be in a universe that seems tailor-made for our existence again. It's almost like we keep winning the cosmic lottery.
Right, but is there any way to test this idea? It's not like we can just pop over to a neighboring universe and check their Higgs mass.
Yeah, I was just thinking that. So how can we actually look for evidence of a multiverse if we can't directly observe these other universes?
Well, direct observation of other universes is unfortunately beyond our reach,
Right.
at least for now. But there are a few indirect ways we might be able to gather evidence. One is by looking for subtle imprints of the multiverse in the cosmic microwave background radiation, the afterglow of the Big Bang.
Ah, the CMB, the baby picture of the universe. We talked about that in our deep dive on the early universe. So how could the multiverse leave its mark on something as ancient as the CMB?
Some physicists theorize that collisions with other universes in the very early stages of the multiverse's evolution might have left behind faint patterns or anomalies in the CMB.
So we're looking for signs of ancient cosmic fender benders.
That's a great way to put it. Of course, it's much more complicated than that, and it's extremely difficult to distinguish these hypothetical imprints from random fluctuations in the data.
I see.
But the possibility is intriguing.
If there really are countless universes out there, wouldn't they be constantly bumping into each other? Wouldn't we notice something?
That's a common question.
Yeah.
But the way most physicists envision the multiverse, these other universes, are not necessarily in close proximity. They could be separated by vast stretches of space and time, perhaps even existing in different dimensions.
Okay, so it's not like a crowded dance floor where universes are constantly jostling for space. More like a vast empty cosmos with islands of reality scattered far, far apart.
Exactly.
Okay, that makes sense. So those cosmic collisions might be rarer than we think. But let's get back to the Higgs boson. You mentioned earlier that future discoveries at the Large Hadron Collider could provide more hints about the multiverse, right? Especially when it comes to the properties of the Higgs itself.
Yeah, you're right on that.
So what kind of discoveries are we talking about?
One exciting possibility is the discovery of supersymmetric particles.
Oh, yeah, supersymmetry. The idea that every known particle has a hidden twin, a super partner. But haven't physicists been searching for these particles for decades with no luck?
True supersymmetry has been elusive so far. But the LHC is constantly being upgraded. And with each upgrade, we gain the ability to explore higher energies and search for even more exotic particles. And as supersymmetric particles do exist, their properties could tell us a lot about the nature of the multiverse.
How so? What's the connection between supersymmetry and the multiverse?
Well, some theories suggest that the mass scale of supersymmetric particles is related to the amount of fine-tuning needed to explain the Higgs mass. If we find that supersymmetry exists at a very high energy scale, it could imply that our universe requires a lot more fine-tuning than we initially thought. And that in turn would strengthen the case for a multiverse.
Because a multiverse would provide a natural explanation for why our universe seems so finely tuned.
Precisely. A multiverse would make it less surprising that we find ourselves in a universe with just the right conditions for life, even if those conditions are extremely improbable from a purely statistical standpoint.
Okay, that makes sense. So finding these supersymmetric particles could be a big win for the multiverse hypothesis. But you mentioned there's another possible discovery that could be relevant, right? Something about the Higgs interacting with itself.
You're remembering well.
Right.
It's called the Higgs self-coupling, and it's a fundamental property of the Higgs boson, describing how strongly it interacts with itself.
So the Higgs boson can be both a loner and a social butterfly.
You could say that. And the strength of this self-interaction is crucial for understanding the Higgs field, which is responsible for giving mass to other particles.
Right. But how does this self-coupling tie into the multiverse?
Well, certain multiverse models predict a Higgs self-coupling that's different from what we'd expect based on the standard model of particle physics.
Okay, so if we measure the self-coupling at the LHC and it doesn't match the standard model's prediction, it could be another crack in our current understanding of physics.
Exactly. And that crack could provide a glimpse into a deeper, more complex reality, one that might include a multiverse. Measuring the Higgs self-coupling with high precision is a challenging task, but it's something that physicists at the LHC are actively working on.
It's incredible to think that these experiments, smashing particles together at unimaginable speeds, could reveal something so profound about the nature of reality itself. But this whole idea of a multiverse, it raises some big philosophical questions, doesn't it? What does it mean for us if our universe is just one of many?
It certainly does. It forces us to reconsider our place in the cosmos and rethink some of our most fundamental assumptions about reality.
That's a perfect lead-in to part 3 of our deep dive, where we'll explore some of those philosophical implications. I'm ready to get existential. Okay, so we've explored some pretty compelling evidence suggesting that this multiverse idea might be more than just a theoretical possibility. But now, let's get philosophical. If our universe isn't the only one out there, what does that mean for us humans?
It definitely shakes things up a bit. For centuries we've been pondering our place in the universe, assuming this little pocket of existence was all there is. But the multiverse, it throws all that out the window.
Yeah. It's a pretty big shift in perspective, right? And it kind of makes you feel incredibly small and strangely connected all at the same time.
Exactly. On one hand, it is humbling to realize that our universe, with all its vastness and complexity, might just be one of countless others. It really challenges that idea that we're somehow unique or special in the grand scheme of things.
That's true. But isn't there also this sense of wonder that comes with imagining this infinite tapestry of possibilities? I mean, think about all the potential variations out there, different laws of physics, different forms of matter, maybe even different types of life.
Absolutely. The multiverse expands our sense of what's possible beyond anything we could have imagined. It challenges our assumptions about what's real, what's fundamental, what's even conceivable.
Like, could there be universes where what we consider impossible here is just everyday reality? Universes where gravity works in reverse or time flows backward?
It's a mind-blowing concept to grapple with. Our understanding of physics is based on observations within our own universe.
Yeah.
But if those laws aren't actually universal, then what is? It raises some really profound questions about the very nature of reality itself.
Yeah, and it makes you wonder if there could be universes out there where things we just dismiss as science fiction, like faster than light travel or teleportation, are just normal.
Who knows? Maybe there are universes out there operating on principles we haven't even begun to imagine. Maybe there are even universes where consciousness itself is woven into the fabric of reality.
Okay, now my head is spinning. But let's bring this back down to Earth for a second. If we're just one civilization among potentially countless others scattered across this multiverse, how does that change our understanding of our own significance?
Well, it's a question that philosophers are wrestling with right now. Some might argue that it diminishes our significance. If we're not the only intelligent life in existence, then do our actions, our achievements, even our very existence really matter?
I see what you mean. It's easy to feel insignificant when you're faced with the sheer vastness and diversity of a multiverse. But I wonder if there's a different way to look at it.
I think there is. Instead of seeing it as a threat to our significance, we could view it as an expansion of our potential. Imagine the possibilities if we could connect with other civilizations across the multiverse. The knowledge we could exchange, the perspectives we could gain it, would completely revolutionize our understanding of the universe and our place in it.
Yeah. It's like discovering that you're part of a much larger family than you ever knew existed. Maybe we're not alone in facing the challenges of existence, and maybe there are solutions out there that we haven't even thought of.
Exactly. And even if we never actually manage to communicate with other universes, the very idea of a multiverse should inspire us to think bigger, to be more open-minded, and to appreciate the incredible diversity and complexity of reality.
I like that. It's a reminder that there's always more to learn, more to explore, and more to wonder about. Even if the multiverse turns out to be just a fascinating hypothesis, the journey of exploring it has already pushed the boundaries of our knowledge and imagination.
Absolutely. And who knows? Maybe someday what we consider speculative today will become scientific fact. That's the beauty of science. It's this constantly evolving quest for understanding, driven by curiosity and the desire to unravel the mysteries of the universe.
Well, this has been quite the deep dive. We've gone from the fine-tuning of fundamental constants to the mind-boggling implications of a multiverse, touching on everything from nature of reality to the meaning of life itself. It's a lot to process, but it's also incredibly inspiring.
It certainly leaves us with more questions than answers, but that's part of what makes it so fascinating. The search for understanding continues, and who knows what incredible discoveries await us just beyond the horizon of our current knowledge.
So to our listeners, if you find yourself pondering your place in the universe tonight, remember that the possibilities might be even more expansive than you ever dared to imagine. Keep exploring, keep questioning, and keep looking up at the stars with a sense of wonder. We'll catch you on our next deep dive into the fascinating world